10 in the grade 9 applied level course, looking at two linear relations. So everything we've done so far has been like one line and reading data off that line and determining rate of change, determining the equation, lots of stuff. Now what happens when we have two, and why do we care about two? And the thing that we care about two is sometimes you can find what's called the solution. And the solution of two linear relations will tell you something about the situation. We'll see that quite clearly in the first example. Okay, so let's slide over to the next page. So in this example, we have Ferd and Dreff, and they're speed skating. And Ferd, he can skate at 10 meters per second. Dreff can skate at only 5. So clearly if they race, it's obvious, right? It's obvious that Ferd's going to win the race. But what if they have a 150-meter race and Dreff gets a start of 50 meters? Now personally, this is one I've always wondered. I wondered if I could run against Usain Bolt, how much of a head start would he have to give me for me to win? And that's kind of what this question is. It's like Ferd's Usain Bolt and Dreff is me, and how much of a head start, right? Well, in this case, let's pretend that Dreff has the head start, and he's got a head start of 50 meters. He runs slower. And if we're going to look at data to begin, and of course, if you were given this question, right, you're going to start copying everything I gave you. But think about this in terms of me giving you the question, and what would you do? Well, I give you this table of values so that you can start figuring out how to make the graph, right? And you don't necessarily, it doesn't ask you that you have to use a table of values, but anyway, in the table of values, at time 0, Ferd's at 0, right? But Dreff's at 50 because he's got his 50-meter start. And then because Ferd can go up every second, he can go up 10 meters, right? 10 meters every second, then Ferd's column goes up by 10, and I'll just leave it to you to fill in the whole of Ferd's column. Similar to Dreff, he starts at 50, but he can go up by 5 meters every second, so every single jump is 5 meters. And so Ferd's rate of change is 10, and Dreff's rate of change is 5. Now, if we're going to graph that, I know that I haven't put this down, but I'm going to assume that you can fill in that table of values without me, and let's focus in on this graph. I'm going to make my just a little bit smaller so we can see the whole thing. Looking at the graph, and feel free to pause, by the way, if you want to get the table in while I discuss the graph, but looking at the graph, what I've done is orange is Ferd, okay? And, you know, I didn't show all the points here, but if you look at the scale that I chose, well, I had to get up to 15 seconds. Time is always my x-axis, right? It's this column here. So I went up to 15, okay? On the y, because I filled in my table of values, I see Ferd, well, that, by the way, there's my answer. Ferd gets to 150 first. So I know the answer without graphing, but we're going to graph it anyway, okay? But Ferd gets to 150, so we need to make sure that in the y-axis, the distance, we get to 150. Remember, it's a 150-meter race. So the orange data, the orange line represents Ferd's journey, and really, if you just look at what happened, I'm just plotting the data point, 0, 0, 10 meters at 1 second, 20 meters at 2 seconds, 30 meters at 3 seconds, etc., etc. Join those dots, make a straight line, make it go forever. Okay? Dreff's equation, Dreff's line, remember equation, line, graph, or table values are all the same thing. Dreff's data starts at 50, and he's going up by 5 every time. So, you know, you can again look at the data once my graph's not absolutely perfect. It should touch right here, right? Because there's at 2, he's at 60. At 4, he's here, and so on and so forth. So my graph isn't perfect, and that's one reason that solving a system using a graph isn't going to be totally accurate, but kind of that's it. Well, here's where all the action. Obviously, there's something important about that point. And if you think about it, what happens? At that point, Ferd, who started way down here at 0, because his rate of change is greater, this is where he overtakes him. This is where he overtakes Dreff. So this is called the solution. Okay, but what's happening at this point is this is where Ferd passes Dreff. Excuse my messy writing. So that point is important. And in another way you could say it in math terms, that's the solution to the system. Where those two lines cross is what we call the solution. Anyway, to get to 150 though, at 150, Ferd gets there first and therefore he wins the race. And that's the font that I have, the text that I have written right there. So at this point, I want you to use what I just told you and look at the next few problems. The first one's this one here. Okay, you can see there's a solution to that system, but you're going to try these problems. Okay, so I'm going to turn off my tape, and you turn off yours. Do the next set of problems, and then join me at the next in the next video.